Hello and welcome to this R tutorial. Today we're going to implement support vector machine, or more commonly called SVM, and after having implemented it on Python, we're going to do it on R. So let's quickly set the folder as working directory, machine learning AZ, part 3 classification, SVM, and here we are. Make sure that you have the social network ads.csv file, and then you can click on this more button here to set the folder as working directory. All good. Now we're going to go to our classification template that we made in the logistic regression section. So let's take everything from here to the end, copy, and let's paste it in our SVM R file. Here we go, and now we need to change very few things. So first we need to create our classifier here, which is going to be the SVM classifier, of course. And then we just need to change the title here for the graph, the training set results. So we're going to specify that it's the SVM classifier. Same for the test set here, SVM. And now let's move back up to create our classifier. Okay, so as usual, we're going to import a library, and this time the library is going to be the most popular library that is used for SVM, which is the library E1071. So there are actually two very popular libraries. It's E1071 and KernLab, and actually I tried them both. We obtained kind of the same results. So you can try the other one too, KernLab. It's actually almost the same parameters. You just need to press F1 to look at the parameters onto KSVM, because the function for KernLab is KSVM, and you can check it out. But right now we're going to do it with E1071. So let's do this. First, let's have a look at the packages here. Check out to see if you have the E1071 library. It is installed on my RStudio because I used it a lot of times, but if you installed R for the first time, then you might not have it. So I'm gonna just write this command here for those of you who need to install it. So install.packages, here it is, and then in parentheses you put in quotes the name of the library, which is named this way, E1071. All right, so if you select and execute this line, it will install the package. I won't do it because it's already installed, but it will do it, I promise you. So I'm going to put that as comment there, and now let's start creating our classifier. Well, first we need to, add this line, library E1071, and that's in case you want to make some automated script that select automatically your library here, because this won't be selected all the time. So you want to make sure that you select it. And now we are going to create our SVM classifier. So as usual, we're going to call our classifier equals, and then here we're going to use very simply the function SVM. So let's do this, SVM. Then let's press F1 to look at the parameters, F1. And here are the parameters, the arguments. So the first argument is formula. So let's add it. So as usual, it's the formula that is the dependent variable expressed using a tilde with respect to all your independent variables, which you represent by a dot. So here we're just going to add formula equals. So first we take our dependent variable, which is purchased. All right. And now we use this tilde here, and then a dot. A dot meaning that we're taking all the independent variables of our data set. Okay, now comma to go to the next argument. Then the next argument is data. So of course that's the data on which you want to train your classifier, on which you want your classifier to learn the data to make the future classification. And of course this data is our training set. Okay, perfect. Comma, let's go to the next argument. The next argument is X and Y, but we don't really care about that. And however, we do care about the type here and the kernel. Because the type, as you notice, there's two types of SVM. There is the SVM for classification and the SVR for regression, which is kind of the same support vector machines algorithm, but there is one for classification and one for regression. So here with this argument type, you choose the classification, and the default type for classification is C classification. So that's the one we're going to choose for type. So let's add here type equals C classification. All right. And now the last very important argument is the kernel. So we're starting with the basics. We're starting with the most simple SVM, which is the linear SVM. So here we're going to choose the linear kernel. And then we're going to try some more sophisticated SVM with some Gaussian kernel. So I will let you find out about the surprise. You can actually try to practice by yourself and play around with the different kernels. If you want to, do the course in advance, that's actually a very good thing, to do a course in advance and then watch the course to compare your work with the content of the course. But for now, we're going to choose a linear kernel. So here we'll input kernel equals linear. All right, and that's all. With these 4 arguments, our classifier is ready. Our SVM classifier is ready. So we're going to select the different steps of our sections of our code. So let's first select this one to pre-process the data. Here it is. Okay, so perfect. We have our data set here, our training set, and our test set. So the dataset contains 400 observations, which are informations about users of a social network, including the age and the estimated salary. In this column, purchased here tells if yes or no the user bought a car when the user got the ad that the car company put on the social network for marketing campaign purposes. And so our classifier, as usual, is going to try to classify the users into the 2 categories. Yes, they bought the car, and no, they didn't buy the car. Okay, so let's go back to our classifier. So the pre-processing is done, and now we're going to create our classifier. Everything should go well. I don't have to select this because mine was already selected. So let's press Command or Control plus Enter to execute. And here it is, classifier created, all good. Okay, and now we can make some predictions of new observations, which are here the tested observations. So let's do it. Wipe red. All right, so let's have a look at wipe red. So these are all the predictions of the test set observations. That is, for each user of the test set, our classifier predicts if the user buys the SUV or not. So let's compare the predictions with the truth, which are contained in the test set. So this column tells the truth about whether the users bought yes or no the SUV, and this are the predictions. There is our SVM classifier predicted whether each user bought yes or no the SUV. So let's look at, for example, so all these first guys here were predicted not to buy the SUV. We have all zeros until the 103. But here, as you can see, we have some guys who actually bought the SUV in reality. It's the 18th, 19th, 20, and 22. So our classifier predicted that they didn't buy it, and the truth is that they actually bought it. So that's incorrect predictions. But let's look at the incorrect predictions in a more efficient way by looking at the confusion matrix. So let's select this line here and execute. And now let's find out about the real number of incorrect predictions. So let's type CM here in the console and press enter. And wow, that's actually a quite large number of incorrect predictions. And by the way, we don't obtain the same result as in Python because we have some random factors in the model, and here we didn't specify a seed, so you might actually have some different results, but the idea is here. So okay, so let's look at now the graph to see how it's doing. So for those of you who actually didn't watch the Python tutorial about SVM, a good exercise is to try to guess what's going to happen. That is, what are going to be the prediction regions? What is going to be the prediction boundary? What do you guess you will see? So I will let you think for a second. You can pause on the video. And right now I'm going to tell you. So as you notice, we chose a linear kernel, which means that our SVM classifier is a linear classifier. So as I explained in the logistic regression tutorials on Python and R, well, a linear classifier in 2D dimensional space is a straight line. So here, I'm telling you this right now, we're going to get a straight line, not to get any disappointment, because I know we improved our model with the KNN before. We obtained a good prediction boundary that caught, those users on the bottom right corner that actually bought the SUV, but who were incorrect predictions for logistic regression. Well, here it's also going to be some incorrect predictions for the linear SVM because it's actually a linear classifier. So let's look at the results right now. Select this and press Command and Control. Press Enter to execute. And here are the results. Okay, so as you can see, that's exactly what I just told you. Those users here with a lower salary and a higher age, well, they actually bought the SUV in reality because the points are green, the points are the real observations, but they fell into the red region here because since the linear classifier is a straight line, it couldn't, make some kind of a curve here to catch all the red points into the right place, and therefore it caught some green points, putting them in the red region. So yeah, that's exactly the same as for logistic regression. Sorry about the disappointment, but don't worry. In the next section, we will introduce a new kind of classifier, which will be, well, the kernel SVM with a different kernel than linear kernel. It's going to be a Gaussian kernel, or even we can try some more kernels. Well, you can practice that yourself. It can be very good practice for you. But here, yes, it's a linear classifier, so basically it's the same as logistic regression. And if we look at the test set results, it's going to be the same. Let's have a look. And here's the test set. Okay, so yeah, same thing. Here we have some users of higher age and lower estimated salary who bought the SUV but fell into the red region again because our classifier is a straight line, and that's the best you could do to classify those 2 points and place them into their corresponding category. So a few incorrect predictions here, a few incorrect predictions here. And if you want, you can count the number of incorrect predictions, that is the number of green points in the red region plus the number of red points in the green region. And you will count the number of incorrect predictions we found in the confusion matrix, which was 20 incorrect predictions. But that's great that we have this result because that gives us the motivation to improve our classifier, improve our model. And that's what we're going to do in the next section. So I look forward to seeing you in the next section and show you how we can substantially improve our classification model. So I look forward to showing you the next level, and until then,